All right, folks. Thanks for joining us today on the June 30, 2022 version of the Long Coffee Break. I have with me today Stephen Pearson from Daikin Applied. He's the Director of Application Engineering for the Daikin Applied Air Handling Unit Group. Today we're going to break away a little bit from product-specific topic and talk a little bit about supply chain issues, the impacts that it's had, and should it affect our designs moving forward, or is it something that we need to just be cognizant of and maybe be a little bit more flexible than we would typically want to be when it comes to specifying and ordering and procuring equipment. So Steve, if you will, please enlighten us.
All right, thanks, Matt. Good morning, everybody. I'm glad to be here. As Matt mentioned, Steve Pearson with Daikin Applied. I've been with Daikin for a little over 25 years now, wearing many different hats, and pleased to be here with everyone. Today's HVAC system, it isn't the electromechanical systems of yesteryear anymore. All the technology is being integrated into a building to get the building efficiency up. It's no longer just about the equipment efficiency, but it's also about the performance of the building. How do we make that complete building operate better? How do we make it operate more energy efficient? And putting all of this technology into the equipment does add some challenges to it. So what has happened with today's equipment? The 90.1 energy code actually has a high effect about the equipment, in which the full load efficiencies have been constantly increasing. Gravitation away from full load efficiency to part load efficiency, the IEERs of equipment, has been the big push. In doing all of that takes more and more technology. The energy code also requires single zone V applications all the way down to 6 and 5 ton units, in which fan speeds have to be modulating. It isn't constant volume anymore, and all of that requires technology. More and more people are doing tighter discharge air control with equipment, adding items as inverter compressors. In the last 10 years, inverter compressor has now become the mainstay. Back when we started to add the equipment or add inverter compressors back in 2010 to the equipment. So taking a look at that technology, what does that do? It adds a lot of different items to it to further increase the fan efficiencies, adding in such things as direct drive ECM plenum fans, 100% modulating, not running at constant volume, it's running at full proportional control to maintain that airflow through the equipment. Heat is no longer the mainstay of being staged heating anymore, whether it is a gas, electric, hot water, whatever you may be using. It's more than likely you've been designing around tighter discharge air control. So you're using modulating gas furnaces, modulating SCR electric heat. All of that is taking technology to integrate into there. Same way on the exhaust side, to better maintain that building envelope and the energy it uses with regards to its building pressure, modulating exhaust fans or return fans to maintain that building pressure precisely and more accurately, not wasting any energy. And then any other ancillary devices such as UV lights or humidifier sections are also taking an analog type signal, requiring some type of a controller to get that done. So what's happening in the industry? When COVID hit, it really hit a downturn in production, demand for equipment. We saw a lot of things happen in the industry with the semiconductor industry almost shutting down. And the big question was, in 2020, how quickly is that going to come back? How quickly are we going to recover for that? I don't think anyone anticipated the horseshoe effect that has taken place for the demand for the system designs in 21 and continuing to 22. Semiconductors, with plants shutting down around the world during COVID and not starting back up as quickly, has really hurt the semiconductor industry. We've all seen the 60-minute news stories on TV in which automotive plants and production lines are being shut down because they can't get the semiconductors. This is also taking effect into our equipment. Logistics, shipping costs are continued to increase. The labor force, I'm speaking to you from Minneapolis, Minnesota, and just driving around. I'm sure it's like Denver, the help wanted signs. At any point in time, we probably have open positions of 150 people for the assembly floor to add to the workforce. And then everyone's nervous about the Russian-Ukraine conflict with regards to oil, steel, how that can have an effect on the world supply chain. The supply chain for all manufacturers has become a global situation. It's not that we're getting any particular component from just the United States, it's worldwide. So as we take a look at the some of the economics on the components for steel, copper, and aluminum, you can see the huge spike in pricing from where we were in the 2020 when the pandemic so forth hit, up through into 21, some huge spikes in pricing for all of our costs going into the equipment. That's why you see suppliers with the price increase in their price increase announcements. Is that going to have a lasting effect? The economists right now, they're saying no, it'll have a decline, but it's very, very slow at best, going out to 24 before it begins to stabilize. The point that I want to make with this slide is you can see though, where it stabilizes in 2014, or I mean in 2024, is nothing like where the supply chain was back in 2018, 2019 for the costs. So how does that affect our equipment ourselves? With the semiconductors and the controls, it affects ECM fans, VFDs, the unit controllers, all the devices that control the compressor operation. DDC boards that are controlling the inverter, the speed of the compressors, VFDs for controlling the supply fans. These are all devices that are being affected by the semiconductor industry. Even within the control panels themselves, a simple thing is a 24-volt control transformer, even a step-down transformer at times has had difficulties in getting. The motor protection devices, manual motor protection devices or circuit breakers fluctuates on supply chain demands. With regards to other items, I've seen things such as spring isolators for supply fans. Other spring isolators are difficult to get, and it shut manufacturing production lines down for days, 3 days before we can actually get them. Running the production line today in just-in-time manufacturing becomes very difficult when you have all of a sudden VFD manufacturers, what used to have a 4-week lead time, all of a sudden switch their lead time to a 50-week lead time. That has drastic effects. So how does Daikin Applied handle that? Some of our products were already suited for that. It has multiple VFD manufacturers that are acceptable, whether it be at Danfoss and ABB, others. Other product lines that we had only had one VFD designed into it. As we come into supply chain issues with a particular manufacturer, now engineering has to go back and redesign control panel layouts for VFDs. ECM fans, as they become difficult to get from one manufacturer, we have to get other manufacturers approved through the quality and supply chain. For both of these, as we were talking about the semiconductors, is it truly going to stay that way forever? No, not at all. Right now, economists are saying by the time we get into Q1, the first quarter of 2023, that the semiconductor industry should come back, and these particular devices should be more readily available. Right now, we have a VFD manufacturer that tells me that I cannot get another VFD until the May timeframe, which was a scramble on the production line to get others designed into it or to get those products switched over that are currently on the line to an alternative design. What does that mean for design engineers? Should you change your game plan on how you're designing a project? No, not really, but you should take into consideration. Some of these components are factory installed, like on a package of rooftop equipment. Other components or other product lines, such as indoor air handlers, for example. An indoor air handler, the VFD can be part of the electrician specification. Instead of operating under just-in-time for VFD supply chain issues, now if it's under the electrical spec, they can plan well in advance in field installing those VFDs if there's an issue of getting them. The unit itself can be installed in the mechanical room, ductwork all installed, and the VFD can come at a later date, saving on the sequence of operation and the critical path for the building HVAC system to get under control. With that, that kind of hits some of the major challenges that we see. And I want to thank you for the time. Matt, you got any questions for me that may have come up?
Yeah, I guess you've hit on a couple of the questions that I was going to bring up initially, but I guess given the issues with the labor shortage, raw material shortage, can you look into your crystal ball to let us know when lead times might get back to what I'd consider kind of the old normal? Is there any indication when that might get fixed?
Right now, it's going to take us a little bit as we change our just-in-time manufacturing process. Never before did we think we'd have to do a materials planning 50 weeks in advance. We're doing and changing our manufacturing and our procurement activities such that when orders come in immediately, that they can go to straight to the supply chain. While lead times are long, we're changing minimum lead times for equipment, indicating about a 13-week lead time is the minimum of it getting in to the factory and released, and that equipment can be released to the purchasing department for the acquisition of those components. Forecasting, buying components in advance before we even have the equipment become more and more critical. Our systems connected to the sales office's system such that we can tell in advance on what material is going to be needed is all key components of reducing that lead time. The lead times itself, as the supply chain come back into line with components, it's going to take the remainder of 22 here, and I would say by the time we hit the spring of 23, Q1 of 2023, that the lead times should start to come back down.
All right. Well, yeah, thank you for that information. And then this next question, you can only maybe speak from your point of view, from a Daikin point of view, but and you've hit on that topic of just-in-time manufacturing. Is that one of the lessons learned that you've had through this? What is that going to be? Is that something that's going to have a lasting impact for decades, or what's your view on that?
I think our systems will change to better suit just-in-time manufacturing. Currently, there's no manufacturer that I know of that can have enough components in stock that could support a 50-week lead time for any particular device. How we do just-in-time, how we forecast to our suppliers, how we indicate demand to them is going to have a lasting impact, and all for the better. Such that as we design multiple sources into equipment, if we have an issue with one supplier, it can be quickly converted over to another supplier. I'll give you an example is for fans, for example. Those are uniquely combined with any type of the heating element. The ETL certification and the certification for that equipment is closely tied together between the fan itself and the heat device. So as I use a completely different fan, that fan would have to be recertified under its ETL listing. All of that takes time. If we do that in advance, that clears it up, and I think we will have in the future more and more particular components have multi-source availability to them.
Gotcha. Well, Steve, I greatly appreciate your participation today. Great insight. I think it's timely. Maybe some of that we've already kind of known a bit, but it's good to hear it's straight from the horse's mouth. So I thank you. So, and if you'd go to the next slide, we can kind of conclude this. For all of you, thank you for joining us today. Thanks once again, Steve. Have a happy and safe 4th of July. God bless America. See y'all.
Thanks, everybody.